So today's topic of discussion is remote sensing and GIS, particularly the fundamentals of remote sensing and GIS. So I myself, Somnath Mukharjee, Associate Professor of Geography, Bankura Christian College. Now I'm going to reveal some of the fundamental issues and aspects of the remote sensing first. Please, next. So let me tell you about the definition of remote sensing. Remote sensing means actually it is having two meaningful words. One is remote, that means from far away or from a distant place above the earth's surface, and sensing means recording something under observation or under study, that is of about the part of the earth's surface or the whole earth. Now I am going to reveal some of the another definitions of remote sensing. Remote sensing is a modern techniques of sensing, identifying, delineating various distinct objects without touching that object, without direct physical contact. Now let me tell you about the main objective or essence of the remote sensing that has been given by the United Nations. United Nations has told us that the major objectives of remote sensing is to understand, is to inculcate and discover the active remote sensing parts. So that's why they are saying that remote sensing means sensing of the earth surface from space by making use of the properties of improving electromagnetic wave. That means that we generally heavily dependent on the sun as a source of energy, main source of energy, to get the information from the earth's surface. But we have to have some of the dependencies on the active remote sensing that has been produced by man himself or herself, and that is quietly an artificial source. And the main objectives of remote sensing should be, that is the purpose of improving the natural resource management, land use, and the protection of the environment. Now, in this era, we know very well that there are so many types of issues and agendas provided by the United Nations, and among them one of the most important is the Sustainable Development Goals, which we will have to reach within 2030. And among them, one is the natural resource management, another is the protection of the environment. Because unless and until we are not engaging ourselves for the protection of the environment, we can't survive ourselves as a human being in this world. Next, please. So now I am going to reveal some of the historical factors of remote sensing, how it is actually developing. The first, it has been developed through photography as a first step in 1826. Thereafter, in 1858, as you can see there, in 1858, the balloon was invented, and it has been used there. Aeroplane invented in 1903. As you can see, our college, Bankura Christian College, also established in 1903. So that is a very remarkable year. And in 1909, the aerial photography from plane was introduced. Now, we know very well that the Sputnik 1957 was the first satellite which has been launched from the Earth's surface, and thereafter so many satellites are there in the above the Earth's surface. Particularly, there are two major satellites. One is the Sun synchronous, and another is the Earth synchronous, or we can say that the polar orbiting satellites and the Earth orbiting satellites, or the geosynchronous satellites. Or next, please. Now, in case of the development of the remote sensing in case of the Indian context, the efforts actually started in the year 1962, as you can see, and thereafter the Bhaskara is the first satellites from the Indian soil. Now we are having so many types of satellites. For instance, we have the satellites like Kalpana 1, named after the Kalpana Chawla we know very well her. So that is actually used for geostationary satellites, for the communication satellites. It has been used for the communication as well as the weather condition of the overall Indian perspective. And we have also used the sub-resolution satellites, sensors, like we have the Cartosat satellites, where we have the resolutions, spatial resolutions of about less than 1 meter. Next, please. Now I am going to reveal about the major stages of remote sensing. There are two major stages of remote sensing. One is data acquisition and another is the data analysis. Now the data analysis is having some stages, like sun as a source of energy. It is the sun, from the sun we are getting the electromagnetic wave, which is having two field, electric field and magnetic field. They are coming into the towards the earth's surface, but before coming to the earth's surface they are propagating through the atmosphere. Next, as a short wave solar radiation, and then interacts with the earth's surface, as you can see here, and thereafter it bounces back from the earth's surface as a source of energy, as a long wave solar radiation, refracted from the earth's surface, and then it reaches to the sensor where it collects the information about the surface of the earth, or we can see that here the part of the earth surface under study, because remote sensing is a very, very costly technology. So we have to have a very precisely, we have to understand that where we are going to field, where we are going to refer, because unless and until we can be a very, it can be a very expensive one. The next stage will be the data analysis, which is a very vital one, and that is actually done on the earth surface by the planners in the GIS environment. As you can see that when it reaches to the sensor, it is actually transferring all the data in the digital numbers or in the pictorial form to the data receiving center. In the Somnath, we are getting such type of data in India. Now all these data are then actually in the GIS environment, they are actually georeferenced, then they are analyzed, because we know that GIS is nothing but the layers of information of the earth surface under study for the analysis purposes. It is the main purpose of GIS, and for the decision makers who are going to make a decisions for the particular issue. Next, please. So as you can see that these are the major stages of remote sensing, data acquisition and data analysis. I have already covered this part. So next, please. So the major advantages of remote sensing is the synoptic view or the bird's eye view. As a human being, we cannot reach so far, and in this regard, the satellites or the aircrafts or the balloons are being used to reach a vast part of the earth surface, that is called the swath area, around 800 kilometer by 800 kilometer, or the 1/3 part of the globe. So as a human being, we cannot reach up to that point. So in that regards, it's a very, very good advantage for us. Temporal coverage means that repetitive coverage means a particular satellites like the polar orbiting satellites, about 200 to 1000 kilometers above the earth surface, they are orbiting earth from north to south to north again, and they are providing repetitive coverage of a particular space under study, particular location of under study. So it is very important to understand. For instance, if we have catastrophe like tsunami, so if the tsunami is happening, so what is going on there, and afterwards, just like for a particular while, what would be the situation in the near future, that can be also covered through that satellites. So it is very important now. So it is so that another thing is this, that as a human being we have to cover, we have to reach so far to understand a particular small region, that is called in geography micro region. So it is very important that here only we can get the information of the Earth's surface very quickly, rapidly, as we can as per our need. Next, that is the updated, means that, as I have told you, in case of the temporal coverage, we can be updated about the information of the Earth's surface, about the information of the environment when we are going for the protection of the environment. And the less field work, it is very important. Economic, how it is economic, as I have told you that it is a very expensive one, but it is expensive when we are launching, where we are going to launch that vehicle, launch pad, from the launch pad. It is very costly one, because we need so many things to do. But when we are going to just launch that, after the launch, it is just quite a few times to just provide information about the Earth's surface, and that's not expensive further. So that is economic. And less field work, in geography, field work is a very important thing, because even after getting that satellite image or the aerial photographs, we must have the pilot project, that means the post and the pre-field study. We have to go to the field for the updation and the validation of that space. So it is required for even the interpreter, even for the image interpreter, that is called that is the part of the image interpretation. And the beyond visible range, because our visible range is actually about from 0.4 to 0.7 micrometer we can see. But beyond that visible range, that is microwave, infrared images, thermal images, even during the cloud coverage, we can gather information or extract information of the field. So it is the advantage. These are the advantages, major advantages of remote sensing. Next, please. Now, as I have told you that we have the active remote sensing. Actually, United Nations promotes active remote sensing. Active remote sensing means that the remote sensing has been done through artificial electromagnetic wave. And in case of the passive remote sensing should be done based on the solar electromagnetic energy. So that is the passive remote sensing, where it is told that if the observation is made based on the electromagnetic radiation from the sun or self-emitted radiance, it is passive remote sensing. Next, please. Next, please. So as you can see that we have another important segment of discussion, that is the platform. Before going to this discussion, I must tell you that in remote sensing we have three major segments, necessaries. One is the electromagnetic radiation, that is EMR, that can be treated as linkage between the source of the energy and the Earth's surface under study and the sensor. And another thing is the object under observation, that can be the whole Earth or the part of it. And another important thing is the sensor. So here another important terminology in remote sensing is the platform upon which we are getting the information. The platform is of three kinds. One is the terrestrial platform. Next one, please. Next one. So this is the terrestrial platform, 1 meter above the Earth's surface, 1 meter means a man can be there to read that Earth's surface. Next please. And another is the 36,000 kilometer above the Earth's surface, and that is actually the space from the space. So through with the aid of the spacecrafts. And another we have got the airborne platform. That means from the air, we have the Chevro, we have Dakota type of aircrafts through which we can get the information about the Earth's surface. Next one, please. So as you can see here, the man is just standing here and getting information about the Earth's surface through GPS and all these things. So it is a part of the terrestrial platform. Next, please. And this is the cherry picker. It's a part of that ground-based platform, but it is actually another part of the ground-based platform or terrestrial platform. Next, please. So this is the airborne platform, particularly in the First World War, and we have used the pigeon for the source of as a source of getting the information from the Earth's surface. As you can see that the bird's eye view here. Now next please. Here we can see that the pigeon is actually has used by the enemies to get the information about the other enemies. So by this way they are getting the information of the Earth's surface. Next one please. Here the balloon has been used even today also. The Pacific nations has been used these type of balloons to get the information about the Pacific weather condition. Next one please. This is the you can see that the airborne platform, the helicopter has been used. Next one please. This is the Dornier 228101, which has been used for the aircrafts as a source of information. They are getting the information of the Earth's surface. Next one please. This is the most vital portion of the platform, that is the spaceborne platform, and it is actually the part of the major function of the remote sensing, that has been done by the spacecraft or the satellites. Next one please. So the satellites are of two kinds, geostationary satellites and polar orbiting satellites. As you can see that this is the polar orbiting satellites, which is actually moving pole to pole, north to south, south to north. It is the average the altitude of that satellite is 200 to 1000 kilometer, and important that satellite that is this important satellite that you have, that the SPOT spot of the France. Another form of satellites is the geostationary satellites, where it is actually situated about 36,000 kilometer, precisely 35,900 kilometer above the Earth's surface. And here we can see that it is having the 0 degree as the latitudes, and as far as the demand of that particular nation, it is having that longitudinal extension. So as you can see that in case of India, here you can see that India INSAT satellite, that INSAT means Indian National Satellites, in case that is the 0 degree and 94 degree east, that is about Dhaka, but it is situated like that, and it rotates at the speed of the Earth's rotation, that is about 1600 kilometer per hour. So geostationary satellites are mainly the communication satellites through which we can get the communications as well as the meteorological type of informations of that particular area under study. Next one please. Next one please. Next one. Next one. Yes. So there are some terminologies that has been used in remote sensing. The main one, as I have told you, is the electromagnetic radiation. We have two major fields, as I have told you, that is electric field and magnetic field. Electric field and magnetic field is going just in the right direction. So this is a picture of that electromagnetic radiation, which actually comes into the Earth's surface as a short wave solar radiation and bounce back from the Earth's surface as a form of the long wave solar radiation. This is a major source of energy from the sun. And in case of the wavelength, as you can see that this is the wavelength, one crest This is the crest and this is the crest. The length between one crest to the next crest is called the wavelength. So that wavelength is very, very important one to understand a particular feature. The next one, please. Next one, please. Next one. Next. Next. Okay. Next. Bas. So in case of the electromagnetic radiation, as you can see, this is the wavelength. So in that wavelength, we are just concentrated here. This is the visible condition, 0.4 to 0.7 micrometer, and we have the range of the spectrum. This is called the bundle of rays having the same type of peculiar characteristics. These are the band like gamma rays, X-rays, ultraviolet rays, infrared rays, microwave rays. So these are the electromagnetic bands. So next one, please. Next, radio waves, right? Next one. These are the visible rays, 0.4 to 0.7 micrometer. Next one. So next one, please. Next one, please. So this is the thermal image, and the last but not least, yes, the previous one, please. No, previous one. This is the spectral reflectance curve. The spectral reflectance curve is a very important curve through which we can understand the reflection or the reflectance value of that particular object, and through which we can understand which reflectance, which at the wavelength is suitable for a particular object. Like for instance, the green vegetation, like 2. That is the 2. This is the signature, and you can see that it is at the highest peak, that is about reflectance about 40%. We have got in around this 0.7 to 1.3 micrometer right here. So here NIR band, that is near infrared band, is the most suitable band through which we can understand better about the green vegetation, because the foliage systems are there, so it is actually reflected heavily, that is about 40% in the NIR band. So next one, please. So this is the atmospheric window. Atmospheric window means where it is a very interesting one, that all the electromagnetic rays cannot come to the Earth's surface, because some of the rays cannot reach to the Earth's surface. We know that infrared radiation cannot come to the Earth's surface. It is a very good one, but one portion of the infrared rays actually comes to the Earth's surface, and that is called that is here we can see the photographic UV, and the other visible lights can appear here, can reach to the Earth's surface through propagation of the atmosphere. Radio waves can come, but ultraviolet radiations, UV rays cannot come, X-rays cannot come, gamma rays cannot come. So these are not countable rays in case of remote sensing. So the countable rays of remote sensing would be the visible, the photographic UV. This is the photographic UV, as I've told you. So radio waves, these can be used for the remote sensing. So just এটাকে নিচে নামাও, তাহলে GIS সম্বন্ধে একটু বলেন। GIS-টা একটু নিচে নামাও আস্তে আস্তে। Now let me tell you about something about the books for the information of the students particularly. So this is one of the fundamental books like George Joseph you can use. George Joseph has been very popular among the students and even among the teachers also, where we can see that he actually he has presented all the details information about the remote sensing through his book. So it is a very good one, and for the GIS purposes there are so many types of books. I can refer one that is called the GIS or the Geographical Information Systems of Prithvish Nag and Smita Sengupta. So it's a very good one. Now, as far as the GIS is concerned, what is GIS? As for the time shortage, I must tell you just very shortly that GIS is nothing but the information which has been collected through remote sensing as you can see there, in the GIS environment, we are getting that information as an input, import that data, and then thereafter in the GIS environment, we can cultivate that data, we can georeferencing that data, we can then thereafter map all those data as per our need. So layers of informations we can put together to understand a particular object, to understand a particular the issues which has been raised by a researcher or the geoanalyst or the planners beforehand. So that is actually GIS. Just একটু নিচে নামো. Actually, GIS has been used in 1960s and popularly it has been used since 1970s. But what has been told by the Bureau that geographical information system is a set of tools for collecting, storing, retrieving at will, transforming and displaying spatial data from real world for a particular set of purposes. And it has some just niche ekটু নামিয়ে দাও তাড়াতাড়ি করে একটু নামো. It has got some components, 5 major components. নিচে নামো, একটা ছবি দিয়ে শেষ করছি, নিচে নামো. These are the 5 major components of GIS. একটু উপরে হ্যাঁ. One is the hardware, second one is the software, third one is the procedure methods, next one the data. Data are of two kinds, spatial data and non-spatial data or attribute data. And the users or the people, that means the experts in GIS and the decision makers. So these are the components of GIS. So through this I must conclude my lecture, and I would think that through this lecture you will be getting a few knowledge about the remote sensing and GIS. And I would like to also thank Dr. Photik Baron Mondol, our principal sir, all the fraternity and the college staffs who are getting involved in this, even the non-teaching staffs like Orpon and you also, they are behind the camera here, my brother. So I thank everyone and the departmental head, Dr. Druhin Chakraborty, and all the other staffs for cooperating us. Thank you very much.